So in cases where we don't have an access to a graph of functions, can we still find the limits of that functions? And the answer is yes. In most cases, you can find the limit numerically, meaning that you create a table of values that around the value x. For example, if you're given a functions f of x equals to sine of x divided by x, and you ask to find the limits of this function when x goes to 0. Can you do it? Yes. You want to create the table, a table of values that includes value of x that around the value x equal to 0. So you look at from the left side of 0, the close value to 0 is negative 0.1. If you go a little closer, you get negative 0.01, and you go a little closer, you get 0.001. And from the right side of 0, 0.1 is a close value to 0. You can go a little closer, and you can go a little closer to 0. And so from each of these x values, you want to find the function value f of x when x equals to negative 0.1. And we found that this is actually f of negative 0.1. If you are curious, how can we find this value here? So f of negative 0.1 is 0.9983, and f of negative 0.01 is negative 0.9999. And if you go a little closer, you get 0.9999. All right, so this is how the behavior of the function as x goes to 0 from the left side is starting as a little lower value here, but it's increasing and increasing to 0.9999. Let's see the increasing pattern of the functions as x goes to 0 from the left. And on the right side, f at 0.1, you get this value, 0.9983, and goes to 0.01, you get 0.999, and 0.001, you get 0.999. So the function value f of x at x goes to 0 from the right side is similarly, it starts from a slightly smaller value and approach to 0.999. And 0.9999, if you round it, it's gonna be around 1. So from both sides of the functions of 0, f of x goes to 0.9999, and from the right side of 0, f of x goes to 0.99. And as you keep going closer and closer to 0, the function value will keep going closer and closer to 1. That means the limits of f of x when x go to 0 is 1.